Now I'd like to have a look at some of the conceptual design features in Revit architecture, focusing on form making and editing, divided surfaces, and custom components. The dissolve form command will remove the surfaces from a form, leaving behind only its defining profiles, curves, and points. So let's say you want to edit several profiles at once, or maybe you need to completely remove a profile from the form, like in the case of this lofted form. The form is too dramatic and I want to simplify it by removing the middle profile. I can dissolve the form, delete the profile, and then simply create it again, using only the top and bottom sketches. Using the same methodology, I could just as easily have added a profile above the form and made a 4 profile loft instead of the original 3 profile loft. Now let's say I wanted to reduce the complex curvature of the front face even more. Sketch editing for conceptual masses is easy and provides the ability to edit individual profiles of any type of form without having to delete the form first. Similar to sketch mode, but even more accessible. So by simply picking the top face of this form and clicking the Edit Profile tool, I enter sketch mode and can change this curve from concave to convex very easily. Now I finish the sketch and see that I've got my updated form. This command works for all types of form sketches, including but not limited to revolve profiles, sweep paths, and loft profiles. In the past, only voids could be used as cutting elements for Boolean operations, and it was difficult to access them again for further transformations. Now solids can be used to cut other solids, so that when the cut is executed, geometry from both forms remains visible. If you need your cutting elements to remain as part of your design, you can do that. Cutting behavior is dependent on the order of clicks when using the Cut tool. You'll see the specific results of the transformation if you hide each of the elements in turn. Right here, I'm using the X-ray tool to demonstrate the results. Another interesting feature that will help your design workflow is the Work Plane Viewer. The Work Plane Viewer is a temporary view window that dynamically aligns to the active work plane and displays geometry associated with that work plane. This feature is valuable when inspecting or editing complex forms. So let's say I've changed the overall form of the cutting element in the model. The top face is now sloping, and I'd like to sketch some lines on this face. I know that Revit will automatically set the face as the active work plane when I move my mouse over it when sketching. But I can also open up the active work plane viewer to align exactly to that face. This view is not a permanent view, and you will notice that it has not been added to the project browser. However, it is an editable view. So now I can see the top face of the form in the view and other related elements. But as my active work plane changes throughout my workflow, the view contents and orientation update dynamically, providing me with an optimized working view at all times. Divided surfaces can be split by levels, reference planes, and model lines. So divided surface patterns can be made up of any combination of UV grids and these intersects. So now I'd like to open up a more simplified version of my form. By default, when I divide the surface on this form, it is split up into 2 directions, with U and V grids. As usual, I can toggle on and off these grid divisions, but now I'd like to show you how to divide the surface with intersects. First, I'll apply a pattern to the divided surface, and then turn off the U-grid divisions. Next, I'll turn on some model lines that I have already created, and using the Intersects tool, you'll see how easy it is to create custom surface patterns for your conceptual designs. This is an extremely powerful tool and extends the capabilities of surface rationalization beyond uniform two-way patterns. The adaptive component is a generalized implementation of the pattern-based curtain panel family. It is designed to handle cases where components need to flexibly adapt to many unique contextual conditions. So now let's open another version of our form, which has a custom curtain system in it. You'll notice that the edge panels are missing, and I'd like to fill those in. One of the most common uses of the adaptive component is to fill in these edge panels. So after loading my new component into my conceptual design, I simply drag it from the project browser to the canvas and click the points which I want it to connect to. This tool provides unlimited control over your custom curtain systems and unlocks a variety of exciting workflows. Here are just a few examples of other ways in which we can use the adaptive component, such as developing more complex modeled forms or even creating structural framing applications.